Good morning, good afternoon, and good evening, and welcome to the technical session 2C, Data-Driven and Smart Utilities. I'm Jia Hong, Principal Urban Development Specialist in Central and West Asia Department of ADB, and I'm the moderator for the session today for 1.5 hours. The topic of the session is so pertinent in today's context. How can utilities effectively tackle challenges of sustainability, and what are available tools out there? I hope at the end of the session, you can find what it means for water and sanitation service providers to be smart, and what are the practical ways to achieve this. We have 5 speakers for this session, which I will introduce in a minute. We will go through 5 presenters first by the presentations first by the presenters for 10 minutes each. And we will have about 25 minutes for the Q&A at the end. If you have questions, please post your questions in the Q&A panel on the right-hand side of your screen. And I would also like to thank the Young Water Profession Rapporteur reporting on this session, Ms. Shreya Gawali, Program Officer of Australia Water Partnership. Okay, so I would like to call on our first speaker of the session, Mr. Angelo Simmons, WASH and Climate Change Technical Lead from WaterAid. Mr. Simmons has 10 years of experience working on the technical and management of community development WASH programs across Timor-Leste, with several international NGOs and international companies on the urban and rural WASH programming. He will present on improving the rural WASH system resilience through the integration of climate change elements and Internet of Things solution in Timor-Leste. So over to you, Mr. Simmons.
Yeah, thanks, Gia, for the great introduction, and welcome everyone for this session. Firstly, I would like to thanks ISF, UTS, and CIMILI for their great collaboration to make this happen. Yeah, as you know, all that this climate hazard, especially in Timor-Leste, is quite common hazard across the region. But I just want to highlight the daily flooding. As you all aware that on 4th of April 2020, it's considerable as the worst in 15 years. That all of the major infrastructure or worst infrastructure, including other infrastructure, the Timor-Leste. This is really huge. I mean, the tragedy of the even that experience with the Timor-Leste as well as even for municipality as well across the Timor-Leste. Next, please. Yeah. Typically, there are two key elements that water at Timor-Leste collaborate with the ISF and including CIMILI to integrate climate resilience in response for the climate adaptation for the Rural WASH project. The first element was the climate sanitation that really integrating to existing WASH programming, Rural WASH programming. And then the second element is how to use the Internet of Things that really upgrading the water level indicators that the water rate installed on 2019 to 2016 to 2019, especially at the reservoir level, how to monitor the water storage to help the community on the water governance. Next, please. Yeah, for the climate change session, just to complement the existing Rural WASH program, as I say earlier, and then the guideline is produced just to help the key WASH actors, especially the implementing partners that WaterAid has, as WaterAid is partnering with the local WASH NGO that implementing Rural WASH project. But there are four main key activity that integrated into WASH programming, Rural WASH programming, that namely on the community workshop 1 and the community workshop 2, as the approaches that we are using is the community-based approach. So the four element is the first one is the climate, diagram impact. That's really on how to identify the impact of the climate change, including identify the climate hazard. And then the second activity is who decide, just to identify, engaging, encouraging the community, how the affecting of the climate change impact, especially the normal situation and the climate situation, the extreme situation, who does and who decide. This is one of the activity. And then third activity is mostly that will be happen on the community workshop 2, that really how to presenting back the feedback, the feedback session, to validate the key finding of the climate hazard, including the rules and responsibility that was identified through the activity number 3. And the last activity is the 5 resources that really identify the local resources, how they can utilize this kind of resource for implementing of the Rural WASH, including using to responding to climate impact, especially for the resilience for the climate change adaptation on WASH. Please, next slide. Yeah, for the Internet of Solution, as I said earlier, that it's really partnered with CIMILI as a private sector social enterprise that based in Timor-Leste. that really upgraded the manual, the local material for the reservoir water level, as you saw in the picture, that digitalized to digital log technology. There are two main foundations for this solution. The first one is it's really a configurable cloud platform, and then power analytic and visualization of data. And then the second foundation is artificial intelligence, is multi-purpose data logger that's installed at the reservoir. That really depending on the internet connection, seamless integration to one cloud platform. So this is really some of the effort that we will started with the Simile in 2019 to digitalize this effort from the manual to digital. That really helping water manager to monitor, including the community, how to govern, how to manage the water itself in the critical situation, especially in the dry season. Next, please. Yeah, typically this solution can be applied for rural and urban, including peri-urban. That really engage in community to manage their water supply system. As you know, some rural areas really challenging the coverage, especially for the lack of resources at the institution level. That can be help the water manager to monitor how the functionality of the water supply system, that not really going down to the field to check, but from the system they can monitor nearly real time to monitor the functionality of water, even for the normal situation, including the extreme situation, especially on the climate change. So currently, WaterAid and Simile install 16 single of multi-tank system that currently monitor with the well sector, including the implementing partners that who has already trained how to use this kind of things. Next, please. Yeah, the data that comes out from the this kind of system is really helpful, especially as you can see on the figure that the change in water, especially inches and then demand during a day, and how we can see the changing of the water during a day when the community access. And sometimes this is really helpful, could be the climate modeling as well, how to see the variability of the water resource. Because one of the challenges that currently Timor-Leste faces, we don't really have like a national data that really helping how to see the changing of impact climate changes, especially for the water resource management and the water supply system, for the uncertainty of the climate change impacting WAS. So this is one of the system that really show us how the changing on the regular basis, even for the monthly and weekly, including daily itself, that really help the water manager. In addition, the output of data could help how to determine the daily consumption of water. That currently the national policies determine the 30 up to 16 liters, but through this model, we can model in how to see the real consumption itself to consider an integrated water resource management for the rural WAS project. Next, please. Yeah, some of the learning and recommendation from this effort, especially on the research, the WAS programming and practice is the first thing is to use the community owned resource to respond to climate change. Community has their own resources to adapt the climate change. In other end, to ensure the changing behavior and sustainability of the community climate resilience, community need to encourage and using their own resources to respond it. And the second one is the climate change impact is diverse for various of social groups. The design need to meet the solution, the diverse need of the social group itself. And then third one is participatory method is effective way how to ensure the climate change assessment, including climate adaptation itself, to ensure the sustainability and the climate resilience effectively at the community level. And for the government and policy programming, government need to fulfill their commitment to support climate resilience for water itself. And then gender and social inclusion must be integrated into government guidelines to ensure that the inclusion and social inclusion met at the project implementation, even for the program itself. And the last one, the coordination between multi-sectoral is a key point that need to be aware at the multi-sectoral level. As you know, that if you want to ensure the climate resilience response, is mean that the multi-sectoral effort. Even currently, we do have like national adaptation plan, but the coordination is still the key challenging. So engaging coordination between multi-sectoral government department at local level is the key aspect need to be considering at the government and policy programming. Next slide, please. Yeah, thank you. The general challenges, especially for the Internet of Things solution, is the one of the coverage of internet connectivity, and then the next challenges is the extreme weather that's really affecting the installation of the system and how to ensure the service of the operational of the system itself. And then lastly, I would like to share what kind of the solution, the takeaway from this project is data logger could send data for rural water supply monitoring system that really effectively to monitor the functionality of the water itself, even for normal situation and extreme situation, that really helping a water manager and community to manage their water stock during the water scarcity and the climate change itself. And then a data logger could, there is a risk value add the local system data information that could be not only for the water supply monitoring system, but including water resource management, where we could using this kind of modeling, how to model in the, variability of water resource, even at the rainy season and the dry season, including at the extreme situation to see the variability, the changing of the water sources. The last one is the team understand the water level sensor could determine tank efficiency. That really especially helping on the water manager, special technical one for the design purpose. I think this is all from me, but lastly, I would like to thank you, Water for Women and DFAT, including Wugifa Club, that really is supporting us for this kind of initiative. I think that's all from me. Thank you.
Thank you, Mr. Simmons. Okay, now I will call on the second presenters, which is on innovation in action, tackling water losses costs. I would like to invite Ms. Sima Kanijo, Imagine H2O Asia, and Mr. Gohul Krishna Govindu, CEO of SmartTerra, for short self-introduction and proceed with the presentation and case study. Thank you.
Thank you very much, Gio. Good morning, everyone, and thank you for joining us here today at the Asia Water Forum. My name is Simar Kanijo from Imagine H2O Asia. Presenting in just a minute will be Gokul Krishna Govindu, CEO of SmartTerra, and Imagine H2O entrepreneur we are partnering with to tackle NRW across the region. So what do I mean by an Imagine H2O entrepreneur? For those who may not be familiar with us, Imagine H2O Asia, led by Imagine H2O, is a Singapore-based NGO that wants to make innovation more accessible in Asia and the Pacific. We do this on one hand by sourcing, vetting, and then supporting water tech entrepreneurs with everything they need to succeed. On the other hand, we build a network of early adopters and create pathways for early validation, including through direct pilot support to de-risk those entrepreneurs for their customers. As an NGO, we draw in diverse actors to build an ecosystem around the entrepreneur, bridging governments, DFIs, utilities, and private players across the water value chain to create new opportunities to learn about and accelerate the deployment of water innovation. I'm excited to have you hear from Gokul, an entrepreneur that we continue to work with along with our public and private sector partners. Follow us on the Asia and the Pacific Resilience Hub or connect with us at Imagine H2O www.imagine.org/Asia, to learn more. But now over to you, Gokul.
Thank you, Simar. I'll just wait for the slides to pop up. Hi, everybody. My name is Gokul, and I lead a company called SmartTerra, and we are a Bangalore, India-based water technology company, and we build AI-powered analytics to help water utilities reduce their losses and improve revenue. So next slide, please. So this is a very common knowledge, actually, that Asian utilities lose up to 40% of water produced. And this loss is basically can be split into two: apparent losses and real losses. Apparent losses are on the customer side or post the meter. And they usually tend to be about 1/4 or 1/3 of the overall losses. But they are very quick fixes and quick soft fixes without needing extensive capex outlay. The real losses are on the network side, and they constitute up to 2/3 or 3/4 of the overall losses. And importantly, fixing these losses involves high capex and quite extensive resources. But the main underlying problem to why we even have such high losses is, next slide, please, is that utilities are failing to draw or extract intelligence out of the data that they already have. So the data that they have collected is actually being underutilized. And this data comes in, in the billing systems, in the SCADA IoT systems, asset management systems. There are various departments and workflows which all contain this data. But on a day-to-day basis, how do I reduce my loss today? What do I do today is a question which is often not easily answerable. And utilities tend to chase losses in a reactionary mode mostly. So existing solutions basically are not able to help utilities with these operational intelligence, essentially day-to-day operational intelligence, because data is in various data silos. Existing meters and sensors are sometimes use proprietary software, and any new IT, ICT infrastructure can be a huge spend on both the financial side as well as the resource side. The utility has to be able to find the engineers to actually dedicate to IT and ICT. And the most important thing which we found is that analytics might produce results, but to tie them to actual field tasks via utility domain expertise, utility operational domain expertise is frequently lacking. So that is a gap which we intended to fill with our solution. Next slide, please. So our AI-powered analytics is accessed by the utility as a cloud SaaS software solution. Our solution integrates with any database or any hardware data that the utility already has. The utility simply has to point us towards that data. And a lot of the times utilities just upload data as well. And the solution provides codified utility operational expertise along with AI analytical algorithms to produce loss analytics and specifically field tasks to go chase either apparent losses or real losses. So how is this done? It's best explained in an example. So next slide, please. So this is one case study of a mid-sized utility in the Philippines, and we are actually thankful for Imagine H2O and a valuable mentor for putting us in touch with this utility in the Philippines. So this utility serves about 40,000 connections. It actually has digital network maps, and some of its workflows are digital. Maintenance and operational workflows are digital, but it had an old network and had up to 50% NRW in various DMAs. And it was engaged in renewing and expanding the network to basically serve a larger customer base, but it had a dwindling or it was facing a bulk water shortage, so it had to reduce its NRW losses significantly. We started out by helping them analyze for apparent losses and helping them improve their revenue essentially. So we provided them a dashboard. This unified data from the network maps and meter readings, etc. The utility was simply able to upload all this data. So there were no database integrations, etc. The utility was able to get analytical results in a matter of a couple of weeks, I think. And we were able to provide revenue and consumption forecasts along with a granular list of meters and customers which we thought had apparent loss issues. So next slide, please. So the utility was provided with a prioritized list of meters and connections that were suspected of apparent loss, and this apparent loss was estimated to be about 4.5% out of the overall 50% NRW. So the key here is that this analytics was provided to the utility in terms of point tasks. So and what you see on the bottom right here is a specific meter, the location, the details, the history, all of it was provided in a task such that the utility could go fix it very easily or seamlessly. Next slide, please. So speaking about the modularity of the solution, so a mid-sized utility is one with a lot of digital network maps, etc. But on the other side of the spectrum, we worked with a small rural utility in Cambodia, which had a new network. So its NRW was quite low, 10%, 10 to 11%. It was serving about 6,000 connections. But what it had in terms of data was just paper network maps and partial digital workflows. The only thing digital here was the billing that it was doing at the customer. So it said we have nothing more than an Excel file with meter reading history. So we analyzed the data, the meter data, and we were able to show an estimated 3% apparent loss, which the utility in a matter of 2 months was able to fix about 1%, field validate about 1% of it in just 2 months. A few things which I want to point out here is that this was a utility which required language support. So they wanted the field task forms, etc., to be in Khmer language. So all of that was possible, and the utilities field operators were able to access this on their mobile phones out in the field. So basically, just a simple Excel upload, the cloud software doing all the work behind the scenes, and the benefit being obtained in a matter of a couple of months. Next slide, please. And going from a small utility in Cambodia, rural utility, to a large urban utility in India. So this utility was in the hands of a private operator. The operations were being run by a large multinational company. The city owned the assets. Now here, because it was a private operator incentivized with reducing losses, they had digitized the network maps, they had the city's environmental profile, demand profile, and they had a good history of about 4 years of maintenance history. But the network was being expanded and was being transitioned from intermittent supply to 24/7 supply. So even though this utility had all this digital data, it still needed analysis in order to understand the condition of the network in a very dynamic fashion. So the dynamic condition monitoring helped the operator to prioritize replacement of pipes, prioritize any particular areas which were seeing a lot of leak fixes, etc., and thus affecting customer service. So they were able to use our NetCity product, which does dynamic condition monitoring of the network based on the maintenance history as well as ongoing maintenance. Sure. Next slide, please. Another example was a large city in India. This was 100,000 connections, and this case study really represents the challenge of data analytics, which is that these 100,000 connections were extremely diverse. There were 20 types of meter, brands, about 40 DMAs, etc. And our MeterCity product was able to analyze this diverse asset base and was able to demonstrate a 3.25% increase in revenue for the utility by reducing apparent losses. So this is a modular solution which can be applicable to a broad range of utilities with a broad range of data sophistication. So if this is something which interests you, please get in touch with us. Thank you.
All right. Thank you, Mr. Govindu. Now, Mr. Kevin Narasimlu, Associate Director of Altereo. Unfortunately, he's unable to join live, so his presentation is pre-recorded. Mr. Narasimlu is in charge of the marketing and forecasting department for the Altereo and is also head of development Ile-de-France Normandy. His presentation is focused on introducing technological innovation for water network asset management.
Hello everyone, my name is Kevin Narasimlu. I'm an Associate Director with Altereo, a French engineering consultancy and innovation company turned towards helping water utilities achieve better performance. My title is Growing a Failure Database with Data Collection Apps for Machine Learning and Failure Risk Prediction. Now, the efficient replacement of water networks which are aging is for me the next challenge for water utilities. Everyone's asking those questions: which pipes to replace, where to start, how to avoid the most failures, how to reduce the most non-revenue water out of every dollar invested. Advanced solutions exist today. We have artificial intelligence bridging serious gaps in this topic. We have machine learning algorithms doing a great job. They are able to learn from past failures to predict the risk of future failures on every pipe in the network. For such technologies to work, we need one thing: we need data. We need a description of every failure, burst or break on the water network that happens every day. We need the date, the location, and descriptive elements of those networks so that we are able afterwards to digest and analyze this data to feed these machine learning algorithms that are able to do a great job with it. So what data is that? On every leak repair, whether it's a water main, a service connection, or a fitting, we need the position. We need to know which object it was: pipe, main, service connection, etc. We need the date, of course. We need the type: is it crack, perforation, hole, etc. And we need a cause. That is something that can be guessed or not, but we need to eliminate accidental causes. And then on the object itself, we need to see what we have: the material, the diameter, which are easy to collect. The age on the spot is not something easy, but that will be data we need to get from somewhere else. But optional data can be position of the pipe with respect to the street, presence of a laying bed or not, type of soil, coating on the pipe, etc. So to help this, to structure this data collection, which is fundamentally important for asset management, we at Altirio have designed an HPO mobile application to help water utilities do that. And the thing is, we decided to give it out to everyone who needs it, no strings attached. So it's free, it's out there, you can use it as from now to facilitate, consolidate and strengthen your data collection for water asset management, because we feel that there's a need for this. There's a need for emergence of good data to do good asset management. And overall, we hope to be able to work with some of those utilities using the app, but we are really giving it out, and you can try it and test it and adopt it. We hope you will. So this is the app screen, which is very simple because it's designed for field agents. There's only one button, record a leak. You choose the type of element the leak is on. That is happening when you are on the repair site. GPS positioning, which can be corrected by hand. Photography, a few information fields to be filled. 5 first ones are compulsory and the rest is optional. It's up to the service and the team to decide. Taking pictures, correcting position, and filling the information required, which are all based on drop-down lists. And of course, this is in English now. We already have French and Spanish. Other languages are really easy to implement. You basically just need to ask and we'll make it happen really quickly. It's designed to happen like that. And as you fill the information, it takes about 20 to 30 seconds to do that. You have lists appearing on what you've collected with your one app. This one app can be attached to one water utility, and this water utility can share its identity to as many agents it wants. So you can have a team, you can have your own private view of your data. No one else is going to look at your data, and you have your team set up within your water utility to use that. I'll give you an example just after. If you want to try it out right now, it's available both on iPhone and Android, and you can scan this QR code. I'll put it back at the end to help you do that. So this initiative, HPO Collect, which is a free initiative, is provided by the French Water Partnership, the Mediterranean Water Institute, and Altirio, because as we developed it, and we also have the support of the Solar Impulse Foundation. Now, why should we look at this? It's very interesting. The first results in Kampala, Uganda, since April 2022, with 10 terminals, with 10 teams going around repairing leaks in the city and collecting information when they repair leaks. They already have nearly 500 leak records in a matter of months, and this is very interesting to do proper asset management later. Now, what happens when we have good data? This is, let's jump in time, jump to another location. This is Noumea in Caledonia in the Pacific. They have been doing this for 11 years, obviously not with the new app, but with their own means. That may be your case as well. If you have good data, you're good to go. They have 11 years of data. The machine learning algorithm will learn on part of that data, and it will find patterns between leaks that happen and different factors like materials, days, ages, soil types, etc. automatically, and it will try thousands of combinations with its computing power to do so and find a good model to explain the leaks in the past. So then it's able to predict the risk of leaks in the future. And for instance here on the next 3 years, but the next 3 years we already know the data that's in there, and we can compare, and that's how the model is able to evaluate its capacity to predict leaks in the future when learning from a certain data set. And we'll look at how this shows in the next slide. But once we have a valid model that is satisfactory, that is very dependent on the quality of data, and that's why we insist on having robust data collection, you can do great things afterwards by predicting the real future, the risk of leaks in every pipe on the network, and then combine this with different criteria like impacts, number of customers, importance of the pipe in the system, etc., and design your replacement priorities for asset management. Now, how do we evaluate a model's capacity? We graph the length of the network against the percentage of failures it's able to avoid by replacing every meter, every percent of the network. And the pink curve is the what we do with at Alterio with our machine learning model on this NUMEA dataset. We are able to concentrate on the 5% of the network length, 44% of leaks in the next 3 years. So the model is really able to go and look out for those pipes that are going to have a failure and concentrate them on a very small length of replacement. 5% of the network is something you can achieve in 3 to 5 years of replacement works, which is very interesting because you're getting absolutely tremendous efficiency results by doing this with a identical, reasonable investment budget. While if you would have done this by ranking your pipes by age, for example, replacing the older ones first, you would have only 12 to 13% of avoided leaks. And if you would have simply followed roadworks and other urban city works, you would have even less efficiency. So it's very interesting to build your asset management strategy using machine learning failure prediction, and you need data for that, and we have the app to get you this data. That's what I was going to say today. The main problem is that our water networks are aging, causing massive leakage on fragile water resources, impacting access to water to populations. On top of that, we have climate change, we have growing demography, we have growing water demand, we have rising energy costs, we have carbon emissions linked to fossil fuels, and all of that can be solved if we are more efficient in replacing the right pipes at the right time in the next years with the same budgets, mastered budgets and mastered cost of water, and drastically more avoided failures and leaks, saving water and reaching higher performance. So if you want to try out this app, really do so. There's a demo mode straight away as you scan this QR code or go to Apple Store and Google Play. It will take you there, but you can also go there manually, look for HPO Collect, download it. If your phone is in English, you'll have the app in English. And you can learn more also on our HPO website. You have my email down there if you want to need any help using the app, if you need new languages, etc. And as I said, it's for free, no strings attached, and really try the demo mode. And if you're convinced with it, you create your water utility. You will have a process to do that. That's very easy. You have a private QR code you can virally share to your teammates. They can literally scan your phone and have the app connected to your water utility. You'll have your private space to view your leaks and store them. We guarantee your data and the privacy of your data and the immediate download of your data to your any system you want, the GIS system. And there you go. We read more on our website, and we're really doing this to encourage and favor better asset management around the world. Thank you for your time.
Thanks to Mr. Nasimlu, we now know that there is a free app that allows the field agent to easily collect and capitalize on essential data every time the person repairs a leak. Okay, so now I would like to call on Mr. Rodney Chapman. He's the founder and CEO of Adora International with US and Singapore-based companies in technology solutions, mergers and acquisitions, advisory, and project development in water, waste, energy sector. Prior to that, Mr. Chapman spent 20 years consulting experience in North America, Asia Pacific, and the Middle East. So I turn it over to you, Mr. Chapman.
Thank you, Gia. Good morning, good evening, good early morning to all of you. It's a pleasure to be here. Today I'm speaking on behalf of Century Water Technologies, which is a company that I became involved with through my advisory role and mentor role with Imagine H2O Asia, who you've already heard from this morning. And we've been doing a project in Vietnam, sponsored in part by Imagine H2O and Elemental Accelerator. So next slide. As Gia mentioned, I've been working in this field as a wastewater process engineer for 30 years. And throughout that time, I've seen many technologies that have been trying to address the problems that we face in managing water and wastewater systems. In particular, in wastewater, we deal with fluctuating influent wastewater conditions, changes in the biological systems, and of course, excessive operating costs and the inability to control energy and chemical use. And we've had limited tools available. We've seen a number of tools come through over the years, monitoring dissolved oxygen, oxidation reduction potential, many other systems. And of course, we have laboratory testing, but none of them have been able to address these problems in real time. Next slide. Century has developed a platform utilizing a biofilm sensor, which you can see on the right-hand side, which can be easily inserted into a pipe or a channel or a basin within a water or wastewater system. And it uses a electrochemical system, which very simply monitors the voltage across a resistor on a biologically active system that responds to changes in biological activity. And they can present this in real time, updated every minute through a cloud-based system, so that operators can monitor the changes in what we call carbon consumption rate in real time. So this is an entire package. It's a platform with a sensor and a cloud-based system, which allows us to monitor these systems in real time. Next slide. Now, this application can be applied in many settings. We can monitor environmental compliance. We can monitor contractual compliance. We can improve operations and improve the commercial and sustainability of systems. First of all, we can apply this system in the wastewater collection system, for example, to monitor industrial pretreatment or to monitor perhaps rain events, dilution of the organic load within the system at various locations within the collection system. Next slide. We can also use this to monitor the wastewater conditions coming into a wastewater treatment plant. So we can see in real time what the organic load is coming into the plant. We can also see toxic events that occur because this system monitors not only organic loading or some representation of COD or BOD, but it also tells us if we have a toxic event, which is very different from any other tool on the market. And so therefore, on the influence side, we can see potential toxicity, we can see the effects of diluted influent loading through rain events, and we can adjust the operation of the plant in order to accommodate that. We also have applied this in the PPP setting because it's a great tool that we've explored with ADB on PPPs to have a real-time compliance monitor for the agreement and contractual influent limits for PPPs. Now, if we look at further into the wastewater plant in the context of aeration basins and biological nutrient removal, we can use these systems to provide feed-forward indication of how to adjust the air and chemical feed systems. We can also apply it in an anaerobic digester setting to, again, prevent upsets within the digester and also to optimize biogas production. In anaerobic digesters, We haven't had a lot of great tools. We can monitor pH and fatty acids, but those are not true indicators of what's happening with the biology in the anaerobic digester, whereas the Sentry system can mimic that in real time. Before we move on from this slide, I want to also say that these systems can be utilized in water supply as well as an early warning system. Because of the sensitivity, they can accurately predict toxic or other types of events in water supplies as well. Next slide. The Sentry system is very easy to install. As I showed you earlier, it's simply a probe which can be installed into a pipe through a fitting that's available off the shelf. It can be installed in a channel, or it can be installed in a tank. And it has all of the connectivity that you would want. The power supply is very low, and again, the data is presented by Sentry through their platform in real time via the cloud. So it's very, very simple. We've installed many of these in Vietnam. It takes less than a couple of hours to install the system. Next slide. So I want to move into what we're doing in Vietnam. We have many applications right now ongoing in Vietnam. We have 2 in the industrial setting, in the municipal setting, 2 in industrial centralized wastewater plants, 2 installed in factory wastewater plants, one a food processing, the other pulp and paper, 1 in a domestic service center wastewater plant, and lastly in an anaerobic digestion setting. I only have time to talk about 2 of these. So if we can go to the next slide, I'll give you some examples from 2 of the applications. The first one is in a municipal setting. It's an SBR plant with a capacity of about 17,500 cubic meters per day. You can see here one of the Sentry installations within the SBR tank. We have 2 sensors installed, one in an SBR, one of 4 SBR tanks, and the other in the effluent. And you can see on the graph on the right, we've overlaid the data from these 2 applications, and the SBR is seen in the light green and the effluent in the dark green. If we go to the next slide, you'll see that the Sentry system is telling us that the effluent quality is going up in this time, and then the operators were able to get it under control. They did not violate permit in this case, but the application was able to show them in real time that the effluent quality is starting to creep up, while you could see that the SBR that we were monitoring was remaining fairly stable. You can see the patterns of the SBR fill and draw, but there was not any extreme changes in the SBR. So in this case, they knew that there was a problem with one of the other SBR tanks. They were able to mitigate that problem because of the real-time indication and get the system back under control. Next slide. The last one I want to talk about is one that's in what I would consider one of the most difficult wastewater settings that we experience here in Vietnam, a centralized wastewater treatment plant that is treating a variety of wastewaters, primarily from textile waste, dyeing applications, but also from some metal plating and from general manufacturing. This is a very complex wastewater plant. It has 2 stages of chemical treatment and 1 biological system. And we've installed the probes in the influent and the EQ basin and following the biological treatment. Again, you can see the data on the right, the EQ basin shown in dark green, so the influent, and then the light green showing after the biological treatment. And if we go to the next slide, you can see that early on in the time period that we're showing, we had a lot of ups and downs in the influent, but the effluent was remaining very stable and very good. Then in the latter part of the data that you see, which is about 5 to 6 days of data, we see that the influent actually dropped significantly in carbon consumption rate. and dropped significantly in its COD, but the effluent remained level and even came up. Now, this application is in the early stages, so we haven't fully optimized, but we're now using Sentry's technical systems and feed-forward optimization systems to help the operators to, in this case, reduce the feeding of air, reduce the feeding of chemicals when we see these drops in the influent. And in this case, we're going to see significant savings because this plant, as you can imagine, because it has a very high loading, has a quite high energy and chemical use. So we're very excited about this application because we've seen how it can benefit the operators. The operators are now convinced, and we're now in the mode of optimizing this system. Next slide. Now, I've talked generally about the system and also about some applications, but I want to talk briefly about the impact that Sentry is having. From our experience, we think that there's not a wastewater treatment plant that could not benefit from Sentry. It's a very cost-effective, real-time system that mimics what's happening in the wastewater treatment plant, advises you of toxic events, but also tells you about the changes within the wastewater treatment plant itself. The Sentry's still in the early days, but they're doing very well. They have now over 150 installation worldwide. They're detecting close to 20 events every day and saving their clients millions of dollars every month, close to $3 million every month, and serving a population now approaching 30 million people. And of course, their system is aligned with the SDGs, Sustainable Development Goals of the UN, and they're having a big impact on the water and wastewater sector. Next slide. Lastly, I'll just wrap up. You can find more information about the systems at Sentry Water Tech, or you can email Sentry or myself, or please also reach out to Imagine H2O. They can connect you with Sentry. Thank you very much for your time.
Thank you. So thank you, Mr. Chapin. That was very informative. The last speaker of the session is Mr. Ryo Takeuchi. Mr. Takeuchi is a senior manager in charge of business development at Light Business Headquarters, Yokogawa Electric Corporation. He has led various business development projects that apply Yokogawa's innovative technologies to customers' potential business issues embedded in their work processes. So I turn it over to you, Mr. Takeuchi. Thank you.
Thank you, Gia. Hi, everybody. Thank you for the introduction. My name is Ryo Takeuchi, and I'm in charge of the marketing of water business at the Yokogawa Electric Corporation. Yokogawa, my company, has been providing advanced digital control solutions, monitoring solutions, and sensors for various industries, including water. And it is my honor to talk about our efforts and outcomes of optimizing potable reuse water with a data modeling technology. Next, please. Next slide, please. Thank you. So we define water stress as water supply capacity against the water demand. Increasing populations and decreasing precipitation bring higher water stress due to the water shortage. We started our project in the United States, and now we are figuring out how to apply our findings and outcomes to Asia Pacific region. And in the United States, southwest to the southeast is facing the worst drought in recorded history. In particular, Los Angeles is struggling with depletion of Colorado River the primary water resource. So next, please. And one of the solutions to the water shortage problem is to reuse wastewater as potable water. Los Angeles aims to recycle 100% of the city's wastewater by 2035. Both, as you can see on the chart, on the diagram, both wastewater treatment facility and advanced water purification facility produce potable water from wastewater. The sequential system attenuate human waste and health risks. They attenuate organic compounds, nutrients by wastewater treatment, particles and pathogens by UF ultrafiltration membranes, chemical compounds and salts by RO reverse osmosis membranes, and trace chemical compounds by UV with advanced oxidation. These contaminants are removed and controlled by engineered buffers, and wastewater becomes potable water. However, wastewater reclamation for potable reuse requires a lot of energy to meet the water quality and sanitization criteria. To lower electricity consumption in such treatment processes, we may apply an advanced data modeling algorithm to the monitoring and control system. And the results will contribute to environmental sustainability and a circular economy. Next slide, please. Okay, we conducted a successful proof of concept of energy optimization at water reclamation facility in Los Angeles. And our collaboration with public and private R&D efforts effectively clarified the user concerns and difficulties in the planning phase. Cloud technology makes it possible to carry out the study even though international travel was not allowed during the COVID-19 situation. And while our R&D team stayed in Tokyo, we got data from the wastewater treatment facility in the US, calculated the best manipulated value with AI, ML, machine learning, and returned the dashboard as the operator requested. And our AI application, which is called data-driven modeling for optimization, or DDMO, gave manipulated airflow rates for better performance and saving energy. Next, please. So we use that technology, data-driven modeling for optimization to optimize the air blowing rate in aeration tanks of a wastewater treatment plant. The POC, proof of concept, yielded a 10% reduction in power consumption with while still meeting the treated water quality requirements. As you see from the ammonia process perspective, it accomplished 24% use reduction, to 24% energy use reduction. Next slide, please. Machine learning applications can also improve membrane operations of a portable reuse facility. Based on the historical data of an ultrafiltration membrane module that successfully predicted the future fouling resistance during production mode and after chemical cleaning. That will help operators longer membrane lifespan. The diagram illustrates the conceptual effects expected when the prediction is applied to the advanced water purification plant operation. Next slide, please. Here, this slide illustrates another application not for potable water reuse, but the same technology can be used to optimize the air blowing rate in aeration tanks of a wastewater treatment plant. The interlink between a distributed control system and DDMO, the AI engine, will also maximize the energy saving effect. We demonstrated the system in a sewage treatment plant of 79 megaliters per day in China. The combination of DCS and DGMO reduced approximately 25% of electricity consumption. In a 3-month evaluation after introducing the optimization system confirms that the blower power consumption and consumption rate were reduced by 25.1% and 24.7% respectively. Next, please. Lastly, we can use Yokogawa's new machine learning technology to optimize energy usage in potable water treatment facilities and potentially increase the lifespan of the assets, including ultrafiltration membranes. And we will continue enabling digital solutions to the other processes of potable water reuse. Thank you very much.
Thank you so much. We've learned a lot today. I thank all speakers for being right on time. So now we've come to the Q&A session, and I see in the chat box, the first thing that I can perhaps address before we get into technical questions is that Roberto Sores, Mr. Sores has asked whether we can access the presentation as reference. I believe so, but I will have to confirm with the event organizer. I don't know if Eileen is still online, or Christian Walder, who may be able to answer this question.
Yes, definitely. All materials will be available at this platform once the event is closed. So everything will be online.
Thank you, Christian. Okay, Christian. So while you are there, maybe you can, pose questions directly to Mr. Gokul.
Thank you. A very quick question for Gokul, basically referring to the minimum data requirements that are necessary for the application for your tool. And maybe you can quickly talk about what are the particular results of this analysis. Are these areas for replacement of pipes or areas for additional meter installations? So maybe you could quickly talk about those 2 points. Thank you very much.
Thank you. So we do end-to-end analytics. So we do both apparent loss as well as real loss. And within real loss, we do real-time monitoring analysis as well as network condition analysis. So this is end-to-end analysis that we are able to provide. This is one of its kind of a solution. Regarding the minimum data that is needed, so our solution is very modular. So we have found that a lot of the utilities will not have network maps or details such as that, but at least they will be doing billing of the customers. So they'll have meter reading histories, and just that in an Excel file is enough for the solution to provide analysis of the meters themselves or of the customers. So the minimum data requirements are very, very flexible. Yeah, so I hope I answered that question.
All right. There's another question for Gokul again from Mr. Puranut. Would you like to turn on your camera, Mr. Puranut, or should I just read out your questions?
I think you just have to read it out. Yeah.
All right. All right. So this is addressed to Gokul again. What is the required data for apparent loss analysis, and how is the apparent loss estimated?
So the required data is basically meter readings, and the history of readings can ideally be 2 years or more. And we analyze the meter readings, we compare it with other customers, other meters, etc. Basically, we do cohorting. This is a machine learning based cohorting approach. And we find the meters which are under registering customers who are potentially using the water for an illegal category. I mean, they are categorized as residential, but using it as commercial. And we look at meters which are degrading, etc. So this we put together some 7 to 8 reasons for apparent loss, either in the meter performance or in the customer consumption trends, and we combine that to estimate the apparent loss. So the estimations are based on multiple kinds of forecasting that we do, and that forecasting considers the consumption patterns according to the rainfall, according to the neighbors, the geographical neighbors, etc. So all of this is part of the machine learning algorithms that look for these apparent losses. And the minimum data requirement, as I mentioned earlier, is just meter readings going back at least 2 years.
All right, thank you. I hope that the response was satisfactory. In any case, now there are 2 questions for Rodney. One question is coming from Mr. Thiam Hua Tan. What technology stacks are used for real-time data capture? That's the first question. The second question is Christian Walder. It's really great to see the innovation, and in particular, the application as a compliance monitoring system. What are the main barriers in mainstreaming the Sentry technology at the moment? Can Sentry measure typical wastewater parameters such as BOD, COD? So that's the third question. Over to you, Rodney.
Okay, thank you. I'm not quite sure I understand the first question, but I just give a little bit more description. So the Sentry technology, as I mentioned, uses this bioelectrical chemical sensor, and what we measure is carbon consumption rate. That's a name that we've given it at Sentry, but it is an indication of how fast a bacterial organism is consuming carbon. And that can be affected by how much carbon is coming in. If there's a lot of food, then it eats faster, or by a toxic event which upsets the bacteria and doesn't allow it to consume carbon. So that's what the Sentry system does. And I'm going to jump to the third question because I think it partially answers this first one and then ties into the barriers. Sentry can be used to indicate COD or BOD generally, because we can correlate it to COD or BOD for a particular wastewater. It differs based on the components of the wastewater. So in cases we have correlated it to COD or BOD, but as I mentioned, it also measures toxicity. So you could have a COD remaining consistent and a heavy metal spike, which would drop our carbon consumption rate, and it would indicate that you have a problem, but perhaps not that the COD has changed. And then I think that answer leads to what the barriers are. Of course, it's a great tool to indicate the relative activity, the carbon consumption rate, relative organic loading, but it doesn't give you an exact COD or BOD. And so some of the barriers that we have seen, certainly on the compliance side, are, well, it's not giving me the number that I want, that I need to certify and write down. So Sentry really can be used as a tool to help operators, a tool to help them give an indication of what's going on in terms of compliance. But there still needs to be the regulatory compliance monitoring to follow that up. But it is a great indicator, and it comes in real time. So we believe that those benefits overcome some of the barriers that you might see. Thank you.
All right, thank you, Rodney. I have a question for you. What are the key challenges and lessons learned from the current deployment of Sentry?
Yeah, thank you. That's a great question. I think anytime you introduce a new technology and something that is not, that hasn't been done before, right? There are challenges. I think one of those is related to what I just talked about. Operators want to equate it to something that they already know. They want to equate it to BOD or COD. They want to know exactly what it's reporting. But what we've seen in Vietnam, I think, and it's a testament to the operators that we're working with, is that they really now see the benefit of what this real-time technology brings them, right? And so they're overcoming this hurdle of, okay, it's not giving me exactly a BOD or ammonia or COD, but it is telling me what's happening within my wastewater plant. And now we're having them actually come to us and say, well, how can we apply it here? Can we do it? Can we use it to optimize this system? So we've seen great, acceptance of the tool. But of course, it's not without overcoming some hurdles, again, particularly in just understanding what the technology is and what it does.
Thank you. That was very, helpful. Now I have another question from Geoffrey Wilson to you, Rodney. Is carbon consumption rate modeled by process simulation models? For example, SUMO.
Yes and no. So we have Sentry has many engineers and wastewater operators actually working for them. Sentry has also partnered with some major consulting firms to develop specific models, feed-forward models in particular, for using carbon consumption rate, because I think, as the question indicates, right, it's different from other simulations and models that we might be using. So they have adapted their own simulation tools for the carbon consumption rate, and they can, of course, share those and employ those with the customers and their particular systems.
Thank you so much. Okay, now there are two questions addressed to Rio. One of them is from Reba Paul. What is the capacity of this particular recycled water plant / system? That's the first question. The second question is also from Reba Paul. Oh no, it's a follow-up comment. I asked this question as the scale of a system also has an influence on energy use. Maybe you can address that first from Ms. Reba Paul, and then we can, yeah. Please go ahead.
Thank you. Thank you, Gia. Sure, can you hear me? Okay. Question number one, the capacity, regarding the capacity, now we are running a proof of concept and it's a planning phase, and we don't have a particular information at this moment. But I would say because that is a proof of concept and planning phase, at this moment, the capacity is not as large as big production site, but in near future, we will expand the capacity up to the required water treatment and potable water reuse capacity for local needs, local demand. And number two, regarding scale of the system or energy use, I'm not sure I understand the meaning of the question, but I actually, there are different parameters and there are different results from different plants, different countries. So it's actually, I would say it's a case by case, and there is no single guideline yet. And we also need to analyze by case basis with different customers. So I'm not sure what the question number two, but did I make myself clear?
Yeah, I hope, I think it was, from Ms. Reba Paul, but I don't know if she can perhaps turn on the microphone. But in any case, if it's not clear, I'm sure, we'll follow up for any clarification after this.
Sure. I welcome. If you have any further questions, please contact me, and I will actually connect to the technicians, engineers, whoever appropriate.
Yeah, actually, there's clarification. Small systems usually have high energy use. That's, I guess that's a statement and a comment rather than a question. Yeah. All right. Another question is from Sarita Sahiharan. Sorry if I misread the name. This is to Rio again. Does DDMO system pay for itself through the benefits it brings?
Thank you. That is a great question. And we actually don't have fixed pricing, or we don't have off-the-shelf products regarding DDMO. And again, it is very difficult to set the right pricing for common throughout all countries, all customers. So it should be absolutely beneficial, cost effective for customers. So we actually we need a careful evaluation phase before the customer decides to pay.
All right. So another question is addressed to Rodney. What kind of maintenance is needed for the sensors? What is the lifespan in typical municipal wastewater application? This is also from Puranot Wisulindapon. Thank you.
Yeah, thank you. It's a great question, and one that we get all the time. The system itself is very robust, right? It's simply a probe that goes into the water stream. The maintenance that is required is only removing it if it gets debris on it or something like that. Occasionally, it gets some growth on it, but typically the operators will see that in the carbon consumption rate, and then they can just clean it and put it back in. And it's very, very easy. They have protocols for cleaning and maintaining the systems. The life, we're still quite early, only a few years of deployment, but we haven't seen any issues with the life. The biological growth, the bacteria that grows on the system is very, very robust. We've put it in some very harsh environments, high pH, low pH, and we've never seen the system actually fail or die and go away. It's always recovered from any shock systems that we've put it into. So it's very, very robust into a large number of settings, and the maintenance is quite simple, just cleaning.
Thank you. There are two questions addressed to Kevin, who is not here today. I don't know if there is a representative from Altereo. If not, we'll make sure that the questions are responded to Viral Akbar and Piranut within that one. I have a question for Mr. Angelo Simmons. For small communities, there are limitations to capacity and resources for, operation and maintenance. How do you, address those?
Yeah, thank you for, I think this is a great question. Yeah, actually, this system is really used in a lack of less of maintenance for that. So the linkage of the operation and maintenance, especially for the rural water system itself, is linked directly to water sectors, especially at the government level. So that's why, as I mentioned earlier, that this system is really helping the water manager, but the benefit of, water governance information data that comes through from the this kind of system is through water manager, through the communication with the community itself. So the operation of the maintenance team is under the water sectors, the government agency or government institution. Yeah.
All right, thank you. So we are coming to an end of the session. Let me try to summarize key takeaway from the 5 sessions today. It was all great. First, Timor-Leste case demonstrated that the practical and innovative approaches in WASH programming to improve the system and community resilience against climate change impact. Then we covered successful innovations is a byproduct of deep-rooted understanding of utility needs, and learned about one solution being deployed with utilities of different sizes and geographical coverage, and share innovative financing mechanisms to encourage uptake of new technologies. We learned about a simple and free mobile application that allow utilities to build databases and sync into predictive asset management, and also robust real-time feed-forward information that is important for better treatment decisions that can also lead to better effluent quality. A bioelectrode sensor is a reliable tool to support feed-forward operation at a wastewater treatment plant. And finally, we learned how data modeling, monitoring, and process control technologies can reduce energy consumption and improve lifespan of the membranes, and ultimately contribute to operational cost reduction, environmental sustainability, and circular economy. I think the common message that throughout was that data is underutilized, and it's also important to have accurate data collection and management, which is critical to asset management of utilities. Now there are, free apps, AIs, machine learning that can help with preventive asset management. I hope I summarized the key messages of our session okay. So I hope you enjoy the session as much as I did, and found answers to what it means for the water and sanitation service providers to be smart, and practical ways to achieve this through the session. I thank again the speakers, audience, and young water professional rapporteurs. And I hope to see you again in other sessions. And thank you. Have a great rest of the day.